So when we look at moving objects, we know about momentum, but now we gotta understand another concept, that's kinetic energy. It's very important. Well, when an object is moving, it has energy, and the energy due to its motion is kinetic energy. So if I am throwing a ball through the air, that thing has kinetic energy. But if I am perfectly stationary in space-time, then I do not have any kinetic energy. Okay, so we look at kinetic energy as if we have a greater mass of the object and the object has a greater velocity, it will have a greater kinetic energy. And the value of this kinetic energy is equal to the object's mass multiplied by its velocity squared and divided by 2. So it's half mv squared, as we more commonly refer to. So if an object has a mass of 5 kilograms and has a velocity of 4 meters per second, then its kinetic energy is equal to 45 joules from 0.5 multiplied by 5 kilograms multiplied by 4 meters per second, and that thing squared. Okay? And another basic concept of kinetic energy is that when we talk about work done, and when a force is acting on an object through a distance, it gives work done. And when it's acting on an object, it's going to change its kinetic energy. It's either going to make it move faster or slower if that force is the resultant force. And the work done is equal to the change in kinetic energy. So the greater the force through the greater distance, we're going to change greater amount of kinetic energy. Okay, more commonly known as W equals delta Ke. And we can derive the final kinetic energy of an object to be equal to the initial kinetic energy plus the work done. Okay, so if a constant force of 5 Newton acts on a stationary mass of 2 kilograms through a distance of 10 meters, we're going to ask what is its Ke. So we know that the general idea is that the final Ke is equal to the initial Ke add the change in Ke, and we know change in Ke is equal to work done for the conservation of energy. And therefore, the initial Ke is 0, and the work done is 5 newtons multiplied by 10 meters. So the final Ke is 50 joules. But what if we were asked the same question, the same details, but to be given a different question, that is to find the final velocity. So we know that the final kinetic energy, so from the previous question, is 50 joules, and we know that kinetic energy is equal to half mv squared, where v is the final speed. And we equate 50 joules is equal to half 2v squared, and we can find v as 7.07 meters per second. See you next time.